So I did number 62 from Chapter 14. A flute is designed so that it plays a frequency of 261.6 Hz, middle C, when all the holes are covered and the temperature is 20 degrees Celsius. A. Consider the flute to be a pipe open at both ends and find its length, assuming that the middle C frequency is the fundamental frequency. B. A second player nearby in a colder room also attempts to play middle C on an identical flute. A beat frequency of 3 beats per second is heard. What is the temperature of the room? Part A. For a pipe that is open at both ends, its fundamental frequency, F, is F1 equals V over 2L, where V is the speed of sound and L is the length of the flute or pipe, whichever one you want to call it. Thus, the length of the pipe is L equals V over 2F meters. The speed of sound at the temperature T in kelvins is V equals 331 meters per second times the square root of T over 273K. So combining equations 1 and 2, we have L equals 331 over 2F. 1 times square root of T over 273 Kelvin meters. At 20 degrees Celsius, L equals 331 meters per second over 2 times 261.6 Hertz times square root of 273 plus 20 Kelvin over 273 Kelvin. And you would get 0.655 meters, which is the length of the flute or pipe. Part B, we are looking to see what the temperature of a colder room is, and that room is where the second player played an identical flute and tries to play it at the same frequency. So F beat equals absolute value of F1 minus F2 equals 3 beats per second, and F2 is rearranging the equation. F2 is F1 plus minus F beat, and plugging in the numbers, you'll get F2 equals 261.6 plus or minus 3 Hertz. So since in the colder room, the length of the flute doesn't change, but the speed of sound is slower, the frequency must be lower. Therefore, F2 equals 261.6 Hertz minus 3 Hertz. You want the minus sign because the frequency must be lower, and you would get 258.6 Hertz. The speed of sound in the colder room is V2 equals 2 F2 times length, and plugging in the numbers, 2 times 258.6 Hertz times 0.655 meters, and you'll get 338.8 meters per second. Since V2 equals 331 meters per second times square root of T2 Kelvin over 273 Kelvin, the temperature of the room is T2 equals V2 meters per second over 331 meters per second squared times 273 Kelvin. Plugging in the numbers, you'll get a temperature of 286 Kelvin, and changing that to Celsius, you would get 13 degrees Celsius.